Hello geometry and welcome to chapter 7, and we're going to begin this chapter talking about the angles in a polygon, which means we need to be able to discuss all the different types of polygons we will be considering. So we're going to be looking at interior measures of the polygons in this lesson, and to do that we need to know what is a diagonal. So a diagonal connects any non-consecutive vertex to another. So it's never going to be the side of your polygon. It always goes through the polygon. So we say it connects any two non-consecutive vertices. And the other thing I want to say about naming a polygon is it doesn't matter where you start, but we don't just haphazardly. So notice this is called A, B, C, D, E. So they started at A and they went around in this direction. I could have also, just as a difference, started at D and gone in the other direction. However, you always want to go by consecutive angles then, okay? You don't just go A, D, B, E, C. So it's really important that when you're identifying your angle, you do it by consecutive vertices. It doesn't matter which direction or where you start. It's just kind of traditional that you start at the lowest letter in the alphabet and work your way up consecutively, but there's nothing that says you have to. Now, what we want to do is we want to kind of show how you can come up with the number of, or with the total sum of the angles in any polygon. So we're going to kind of do it like a derivation. So if you have three sides, that means, I'm going to do a little picture here, that you have a triangle. And we know in a triangle you can't have a diagonal. There's no way to draw it. So there is not going to be any diagonal created. But we do know that the number of triangles formed by diagonals. So you're only going to have one. I think I don't want to put nothing there. You're only going to have one triangle created in a triangle. And so we know the sum of the angles is 180. Now we're going to move on to four sides, which we call a quadrilateral. And in a quadrilateral, notice that if I just choose one vertex, I can only draw one diagonal, which gives me two triangles there. And since each triangle has a 180-degree sum, it makes sense that this is going to then be 360 degrees, is the total sum of the angles in a quadrilateral. If you have five sides, and I'm not going to be able to draw all of these, but I'll do as many as I can, this is called the pentagon, which is actually shaped in that form. If I choose one vertex, notice that I can draw two diagonals. Those two diagonals create three triangles. 3 times 180, because that's what you're doing each time, 3 times 180 gives me a sum of 540. Basically, hopefully you are seeing there's a pattern. We're just adding another 180 each time we do this. So then we come down to 6 sides, and 6 sides is going to be a hexagon. And as you can hopefully see this pattern, if I pick one vertex and draw a diagonal, I would come up with 4 triangles. 4 times 180 gives me 720 is the sum of the angles in a hexagon. And then we start over again. So now we have 7 sides, which is going to be called a heptagon. I know some people want to call it a septagon, and I'm not sure where that comes from, but it does also make sense. So this will be a 5. It would create 5 triangles if I drew the diagonals. And it's 5 times 180 is actually 900. And then we keep going. We got here 8 sides would be an octagon. And the number of triangles formed would be 6 of them. 6 times 180, again, we're adding 180 each time, so this will be a total sum of 1080. 9 sides is going to be what we call a nonagon. And so that would give me 7 triangles from one vertex created by the diagonal, and this will be 1260 is its sum. Then I have 10 is a decagon. If you speak Spanish, 10 for 10. So there'd be 8 here, and then that's going to give me 1440 as the sum of the angles in a decagon. And 11 is going to be 1 plus 10, so this is the undecagon, uno plus 10, undecagon. So this number of diagonals column is not really important unless you're doing the derivation. What we really care about is the sum in each column. So you are going to want to be able to find that sum. Let's finish off with our 12, which is 2 plus 10. 2 plus 10 makes this dodecagon. So you do want to know these names up through 12. And 10 times 180 is 1800. If I had n sides, you would call it an n-gon. All right, so when you have an n-gon, then you can find the sum of the angles by the following formula, polygon interior. So the sum of the interior angles of a polygon can be found by this formula. The sum would equal 180 times n minus 2. So notice if I had a triangle which has 3 sides, the sum would be 180 times 1. Quadrilateral would be 180 times 2, which is what we did, and et cetera, et cetera, et cetera. So what this represents in this is your n minus 2, is what that column represents. Then we have, in particular, the corollary, which is really just about a quadrilateral. Why we need a separate one, I don't know. But the sum of the interior angles in a quadrilateral is 360 degrees. Okay, because those are the most common. So a triangle and a quadrilateral. You really should know up through a hexagon, just kind of as we move forward, not necessarily right at this second, because those are going to be extremely common. All right, so then now let's look at, we've got ourselves an octagon. So an octagon means that n is 8. So to find the sum of the interior, you're going to go 180 times 8 minus 2. So that's 180 times 6. And yes, I know they have the answers up there, but I just wanted you to see how you would do it when you don't have that right in front of you, okay? And an 11agon, same thing. You would do your 180 times 11 minus 2, which is 180 times 9, and that's going to give you your 1620 for the total degrees, measure of the angles. I guess these should all have little degree signs on them. Okay, now we're going to get into this concept of an exterior angle. And remember we talked about a little bit about exterior angles, where an exterior angle is when you take the side and you extend it as you're going around. It kind of creates this pinwheel effect. So 1, 2, 3, 4, 5, those are the exterior angles in a pentagon. But this is really cool, and I will try and show you in class a little illustration of why this is the case. But the sum of the exterior angles, so if we added up, like in this one, angle 1, 2, 3, 4, and 5, we add them up, the sum of the exterior angles of any polygon equals, drum roll please, 360 degrees, always, no matter how many sides. It's kind of cool. So for instance, I'll just do a little bit of like if I had a triangle, let's say this was an equilateral triangle. So all the angles are 60, which means all the outside angles would be 120, their supplement. Well, 3 times 120 is 360. Let's take a square. So if I extend all the sides of my square, so I know all the outside angles are also going to be 90. 4 times 90, what is that? 360 degrees. And we could keep going and going and going. It's kind of cool. And it's also really easy to remember because it's just this one number. It doesn't change. One thing also just to also remember is that every exterior angle and interior angle will be supplementary. So the two of them always equal 180. But that's from before. Okay, let's do an example of this, see how this plays out. The sum of the measures of the interior angles of a convex polygon is 1620. So they want us to find the number of sides. So what we could do is we have our formula 180 times n minus 2. In this case, they're telling us that that equals 1620. So to solve this, I, rather than distribute, like to divide first. Really doesn't matter, but my preference. So that will go away. And I have that n minus 2 is going to equal, when you do that, that equals 9. And then we add 2 to both sides. So we know that what we have is the undecagon. There used to be this commercial called the Uncola, which was for 7-Up. So it always makes me think of that, the undecagon. All right, now they want us to find the value of x in the diagram. So x is right here. I see that I have 4 sides, so I know that the total should equal 360. So we're going to have 360 equals 45 plus 65 plus 95 plus x. So we can then just subtract 360 minus 45 minus 65 minus 95 leaves me with x equals 155 degrees. All right? Okay, so for our next example, we want to find the measure of x, but now it's our exterior angles. So I'm going to add them all up. I know that 2x plus 67 plus 89 has to equal the sum of the exterior, which is 360. So I have that 3x is going to equal 360, take away 67 and 89 is 204. And then when we divide both sides by 3, we get that x is going to equal 68. And I'll put a degree sign on it because there's x by itself. Okay, in example 5, find the value of x in the diagram. Same thing. So I see I have a 4x and an x plus 98 plus 162. We know that has to equal 360. So we have that 5x, when we add these together, equals 360. Take away these others, leaves me with 100. So x is going to equal 20. All right. Then it wants me to find the sum of the interior angles. Well, I have 4 exterior, which means that I have 4 interior. So we know that if it is a quadrilateral, you would have 2 triangles, which equals 360 would be the total of the interior. Now we want to kind of get some of our notation down and our terminology. An equilateral polygon. So remember, lateral means sides, equal is equal, equi. So this means all the sides are going to be congruent. Equiangular, just as it sounds, all the angles are going to be congruent, like in a square or in a rectangle. But a regular polygon is when you have all the sides and the angles congruent. And that would be like in a square. A square, all the sides are congruent, all the angles are 90 degrees. But we will be looking at some special properties of regular polygons as we move through this chapter. All right, here we have a home plate for a baseball field. Is the polygon regular? And so when you look at this, we see three 90-degree angles, but these at vertex E and C, these are not 90 degrees. So this would be no, because not all angles are congruent. And they want us to find the measure of C and E. All right, well, since it's a pentagon, 5 sides, we know that the sum is going to equal 540. So I have 3 that are 90 degrees plus 2 I don't know, and together that has to add up to 540. Well, 3 times 90 is 270. So we have that 2x is going to equal 540 minus 270, which is also 270. So each of those side angles is going to be 135 degrees. So this is 135 and this is 135. All right. Now we have a trampoline. Oh, I know someone who wants to buy a trampoline. So if we look at this, we have to go through and count how many vertices. So kind of walking around, sometimes I find it helpful to kind of mark them as you go around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, oh, silly me. It told me right here, dodecagon. Ha, see, there's a lesson for you. Always read the whole problem first. Okay, so we know we have a dodecagon, 12 sides. Find the measure of each angle. So that's going to be n minus 2 times 180, where n is going to be 12. So let's actually fill that in. And that's kind of nice because 10 times 180, you're just adding a 0 at the end. So that's the sum of the angles. Then it wants us to find the measure of each interior angle. Well, 1800 is the sum of all of them, and I have to, since it's regular, I can then equally distribute that measure among all 12 angles. Tells me that each angle is going to be 150 degrees. Now in the next one, find the measure of each exterior angle. Well, I know the sum of the exterior is 360, so distribute that among all the 12 angles. Tells you that each exterior angle would be 130. Notice that these two are supplementary. So every interior is 150, which means every exterior should be the supplement, which is 30 degrees. All right, this last example, this is kind of important because this is a little bit of a trick. It says find the measure of one interior angle of a regular polygon is 156. So I'm just going to draw, we don't know how many sides it has, but I know that one angle here is 156. That also tells me that the exterior angle has to be 24 degrees. Phooey. I touched something I wasn't supposed to touch. 24 degrees, okay? Because those two have to be supplementary. So I can't finish off the whole thing because I don't know how many sides there are. That's what we want to find. Find the number of sides. In other words, find n. Now the reason why I found that exterior angle, because there's 2 ways to do this problem. There's an easy way, and there's a really kind of algebraically sophisticated way. And always you should choose the easy way. I know that the sum of the exterior angles is 360 degrees. So if I divide that by the 24 degrees that each exterior angle is, what I get in response is 15. So I know that there are 15 sides to my polygon. So n, the number of sides, is going to be 15. What I want to get across to you is whenever possible, try and use those exterior angles because it makes it so much easier. Otherwise, the hard way to do this, I'll kind of do it in a different color, would be I would take n minus 2 times 180, remember we don't know what n is, divided by n, divided by the number of sides, equals 156. That is the equation you would have to solve if you do it by the interior angles. So the moral of that story, of that example, is always, whenever possible, try and utilize your exterior angle since it's always a constant of 360. Okay, so here's a nice little summary chart that you want to keep handy. So the interior, the sum of the angles, is found by doing 180 n minus 2. The exterior angle is a nice constant, and again, this is the sum. So that's all of them together. If all you want is one angle, then what you're going to do is you're going to divide by n. So this would be 180 n minus 2 divided by n gives you one particular angle. Over here we have 360 divided by n equals one angle. But I want to remind you what we just did is 360 divided by one exterior angle equals n. So this works both ways. All right? I hope that makes sense.